So today we are going to continue section 7.6 talking about linear inequalities. This is on page 26, it's the bottom of page 26 and 27 of your packet. We're going to look at two different word problems today and see if we can try and read through the question and set up a system of inequalities, just like we did in the first part of the chapter where we read through a little paragraph and tried to set up a system of equations. So now we're thinking of it in an inequality form instead of an equation form. So this problem talks about a portion of a liquid diet. So think about the different diet drinks that exist out there right now. And it has 300 calories, 36 units of vitamin A, and 90 units of vitamin C. A cup of drink X has 60 calories, 12 units of vitamin A, and 10 units of vitamin C. And then we have a different dietary drink, and that's drink Y. A cup of that has 60 calories, 6 units of vitamin A, and 30 units of vitamin C. It says we want to set up a system of linear inequalities that describes the minimum daily requirements for the calories and vitamins. So, anytime you read a word problem with a lot of numbers, read through it again a second time. So kind of just skim through the information a second time. We know we have two different drinks, drink X and drink Y. So I'm going to have two variables. And we're talking about the number of cups that we would have. So number of cups of drink X, number of cups drink Y. All right, so that's the first step. Think about the variables we want to use. And then the second step is there's three different pieces of information being given. So one piece of information that's given talks about calories. So we probably need to group the calorie information together and try and write an inequality. It says we have to have at least 300 calories. So at least means greater than or equal to. And X has 60. Drink Y also has 60. So that represents our calories, and it's an equation to represent the calories. So if we use that same format, looking at the second group of information, talking about vitamin A, 36 units of vitamin A, 12 units of vitamin A, 6 units of vitamin A. So again, at least 36 units, at least means greater than or equal to. We have 12 units with X and 6 units with Y. All right, the last vitamin they talk about in the problem is vitamin C. And we have at least 90. And then 10 units of vitamin C, 30 units of vitamin C. So 10 with X, 30 with Y. And again, at least 90. The other two pieces of information that we need to include on here are called our obvious inequalities. When we're talking about a word problem, we can't have a negative amount of calories. I'm sure some people would enjoy having a negative amount of calories, but that doesn't exist. So because of that, we cannot have a negative amount of cups of liquid that we would drink either. So we list these last two obvious inequalities because I can't have a negative amount of cups that I would drink of a liquid. It doesn't exist. So X is greater than or equal to 0. The number of cups have to be greater than or equal to 0 for both X and Y. So this asks us to set up the system of inequalities, which we did. And then we're going to see if we can try and graph it. Of course, to graph, we need to create these three equations to be in y equals form. And they look like they could be ugly, but I think they're going to work out pretty nicely. So that first equation, y greater than or equal to, if we take the x to the other side, divide by 60, we would have a negative x plus 5. Our second equation, again, taking the x to the other side, dividing by 6, leaves us with negative 2x plus 6. And then our final equation for vitamin C, taking the x to the other side, dividing by 30, leaves us with negative 1/3 x and then plus 3. So all of those look nice. When we have a system and we're graphing them, we know that it's going to be positive, so I'm just going to make my x and y axis be on the edge of the grid that's given. I am going to label it because we are talking about an actual word problem. So we're thinking about cups of x and cups of y. And then based off of these numbers, each one of these blocks can just be 1 because we're only going up to 6 on the y-axis. I'm just going to label a few. If we had bigger numbers, we might have to count by 2s. Sometimes we might have to count by 5s. But in this case, those numbers are pretty small. And then we're going to graph it. So the first one goes up to 5 and has a slope of negative 1. The second one goes up to 6 and has a slope of negative 2, so they intersect. And then the last one has a slope or an intercept of 3 and a slope of 1/3, and they also intersect. So intersection points, kind of bolding them. And then looking at the information, it's all greater than or equal to. So we're going to be greater than these 3 lines. I'm trying to darken in those 3 lines that we're shading above. And then we're shading all of the information above. So it says that we want to see information or the number of cups that we would have to drink of this liquid portion of our diet. And that's the minimum requirement. So anything in the shaded area would be the number of drinks that we could have of each cup of this dietary portion of our diet. Sometimes these questions might ask us actually to solve for a specific requirement. Other times it might just say give a couple of different options. So anything in the shaded region would be an option. So that's one application problem that we're going to look at. The second application problem is on the next page, and this one actually doesn't require graphing. So this one we're just writing the constraints, which would be the inequalities. Constraints and inequalities are the same thing. So we're coming up with a set of inequalities or constraints, and then it says to write the objective quantity, and we're going to talk about that as well for the following problems. Finally, it says in words, explain what you would need to do to solve the problem, but we're not actually going to solve it. And that's how your homework tonight is going to be. So the homework tonight is going to be setting up the inequalities, the system of inequalities for the word problem, but we actually wouldn't go through solving it. So looking at the problem here, you're selling candy bars and lollipops to raise money for a trip. You are designated the math whiz of your club. So maybe you want to go to the science museum because you're in the science club and you're selling candy bars and lollipops. So your goal is to figure out how many lollipops and how many candy bars you need to sell in order to earn the most profit based off of the information that's given. So they first talk about the cost of the candy bar being 25 cents and the cost of the lollipop is 15 cents. You're going to sell them for 75 cents and 50 cents. So that's what you will end up selling them for. You have $200 to cover the cost of the order. So we have cost, 25 cents and 15 cents, and then the $200 you have to cover that cost. You know you can sell at least twice as many lollipops as candy bars. The company you're ordering them has a minimum order requirement of 50 of each item. In order to get the most profit, how many lollipops and candy bars should you order? So as we did with the last problem, read through it again. Think about what you want to use for x and y. So if you want to use x and y, fine. If you'd rather use L and C, you can do that as well. But I'm going to let x be my candy bars and y be the lollipops. or you can use C and L. So just like we did the previous problem, read through a second time and kind of decide what information you can group together. So similar information, what could we pull together? And I know the first sentence talks about cost, and then the third sentence talks about cost. So the cost of the candy bar is 25 cents. The cost of a lollipop is 15 cents. I have $200. I can't spend any more than that. So that means less than or equal to 200 is the amount of money for the cost. So it costs me 25 cents for each candy bar, 15 cents for each lollipop. Together that cost has to be less than or equal to 200. It could equal, it could be less than. The next sentence says, you can sell at least, that's important, twice as many lollipops as candy bars. So at least means greater than or equal to. And then it says twice as many lollipops, which is Y, as candy bars. So that means that my lollipops are going to be double the amount of candy bars because I'm going to sell more lollipops. So the lollipops is Y. I'm selling twice as many lollipops as candy bars. So if I sell X candy bars, 2 times that would be the number of lollipops I sell. So again, that's a little tricky there. At least means greater than or equal to. Twice as many lollipops as candy bars. So I'm selling more lollipops than I am candy bars. So take the candy bar amount and double it. And that's how many lollipops I would sell. The next sentence says the company you're ordering from has a minimum order requirement of 50 of each item. So minimum order means that I have to at least sell 50 of each. So 50 of lollipops, 50 of candy bars, or 50 of candy bars, 50 of lollipops. So because we have this minimum order, I don't need to say that X has to be greater than or equal to 0, Y has to be greater than or equal to 0, because we have a restriction, and it has to be greater than or equal to 50. So that would be the restriction that is given. That forces them both to be bigger than 0, of course, since we're starting at 50. There's one other piece of information that's given, and that deals with the amount that you're selling it for. And it says we're supposed to find the objective quantity. Our goal is to find profit. We want the most profit. Well, the objective quantity deals with how we can get that most or that largest amount of profit. So an objective quantity is an equation that represents how we can find a max amount of money. And in this equation, we're dealing with profit. So the way we can find profit is by taking what we're selling something for and subtracting the cost. Anything left over is profit. So we're planning on selling our candy bars for 75 cents. It cost us 25 cents. That means the profit on them is 50 cents. So profit is the amount that you will make after you take away the cost. We plan on selling the lollipops for 50 cents. We're paying 15 cents, so that means the profit is 35 cents. So this profit equation is called our objective quantity. It will enable us to kind of determine how many of each we can sell so that we can earn the most amount of money. So we have our constraints. These constraints are known as a system of inequalities. We have the objective quantity, which then we would use to figure out how we can earn the most amount of money. So if we were actually to solve this, we would first graph it. After we graph it, we would look for where the lines connect. Where the lines connect are called our vertices. Those vertices we would then use in the objective quantity to determine which set of vertices give us the most amount of money. So your homework is the next page in the packet, and it's actually front and back. There are 7 problems. Make sure that you label your variables. What does each variable represent? And then you're writing a system of inequalities to solve the problem. But you are not solving the problem. So you're going to do it exactly like we just did this problem here. Hope you have a good day. If you have any questions, send me an email.